Solve the difference equation un plus 2 minus 6un plus 1 plus 5un equals 0, given that u1 equals 0 and u2 equals 20. Now, in the last video, I showed that un equals p alpha to the n plus q beta to the n is a general solution of a second order linear difference equation. By a general solution, I mean that p and q are arbitrary numbers. P and q can be any numbers. Alpha and beta are the roots of the characteristic equation associated with the difference equation. The characteristic equation can be got by replacing un plus 2 with x squared, un plus 1 with x, and u1 with 1. Just remove un. So, I'm going to get alpha and beta here. We just solve this quadratic equation. This is also known as the characteristic equation. It can be factorized into x minus 5 by x minus 1. And from that we get the two roots, x equals 5 and x equals 1. So you can call one of these roots alpha and the other one beta. It doesn't matter. So I'm letting alpha equal 5 and beta equal 1. So we get p times 5 to the power of n plus q times 1 to the power of n. So this is the general solution. 1 to the power of any number is just 1. So we can simplify this to p times 5 to the power of n plus q. Now we have to get what's called a particular solution. And that's where we use values for u that are given here. There are two values of u given. We know that u1 equals 0, so we can start with the general solution, plug 1 in for n. So we plug 1 in here, we get p times 5 to the power of 1, or p times 5 or 5p, plus q equals 0. Then we use the fact that u2 is 20. So we plug 2 in for n into the general solution, so we have p times 5 squared, well that's 25p, plus q, and we're given that that's equal to 20. So we have two equations and two unknowns. So I'll write this second equation here for u2 underneath the first equation. And I'll simply subtract them to get rid of q. So we have 5 minus 25p, that's minus 20p. Q minus q is 0, 0 minus 20 is minus 20. So we get p equals 1. Knowing p, we can find q. If we plug p equals 1 into this top equation, what do we get? We get 5 times 1, or 5 plus q equals 0, which means that q equals minus 5. So now we can write down a particular solution. So here it is, I'm writing it over here. P is equal to 1. So we get 1 times 5 to the power of n, which is just 5 to the power of n, plus q. Q is minus 5. Now, as an extra exercise, I just want to check that this is indeed the solution of the difference equation. First of all, I will check these initial conditions. Let's get u1. If you plug 1 in for n here, you get u1 equals 5 to the power of 1 minus 5. Well, that's 0. That checks out. Let's get u2. Plug 2 in for n. 5 to the power of 2 is 25. 25 minus 5 is 20. That checks out as well. Now the next thing I want to do is sub the solution into the difference equation. So we need un plus 1 and we need un plus 2. To get un plus 1, we just replace n with n plus 1. To get un plus 2, we replace n with n plus 2. So now the difference equation becomes 5 to the power of n plus 2 minus 5 minus 6 into 5 to the power of n plus 1 minus 5 plus 5 times 5 to the power of n minus 5. And hopefully all of this will work out to be 0. Now what you should do here is factorize 5 to the power of n plus 2 and 5 to the power of n plus 1. 5 to the power of n plus 2 is factorized into 5 to the power of n times 5 to the power of 2. Then we have minus 6 times this here. We factorize this into 5 to the power of n times 5 to the power of 1. And we leave this alone. So we just have powers of n. We don't have powers of n plus 2 or n plus 1. The next thing we do is we take out 5 to the power of n. We factorize 5 to the power of n out of this. We have a 5 to the power of n by 5 squared. Well, 5 squared is 25. We have a 5 to the power of n times minus 6 times 5. Minus 6 times 5 is minus 30. Finally, we have a 5 to the power of n multiplied by 5. After that, we just write down what's left. We have minus 5. We have minus 6 by minus 5, which is plus 30. We have plus 5 by minus 5, which is minus 25. Everything has to work out to 0. We get 5 to the power of n times this here. Well, this is 25 minus 30. Minus 5 plus 5. This is 0. And this works out to 0 as well. So the whole thing works out to 0. In part 2, we want to find an expression in n for the sum of the terms u1 plus u2 plus u3 up as far as un. So this is what we get. u1 is got by replacing n with 1. So we get 5 to the power of 1 minus 5. u2 is got by replacing n with 2. So we get 5 squared minus 5. You can see the pattern. u3 is got by replacing n with 3. So we get 5 to the power of 3 minus 5. Finally, un is 5 to the n minus 5. Of course, we're just adding, so we can just drop all the brackets. We don't need it. And we can rewrite this thing as 5 to the power of 1 plus 5 to the power of 2 plus 5 to the power of 3 all the way up to 5 to the power of n. And then we have the minus 5 terms. This first part is a geometric series. The first term a is 5, 5 to the power of 1 is 5, or the common ratio is also 5. Because if we take the second term, 5 squared, and divide by 5, we get 5. So we multiply 5 by each term to get the next term, and so on. How many terms do we have? Well, we've got n terms. Sn for a geometric series is a into 1 minus r to the power of n divided by 1 minus r. So a is 5 into 1 minus 5 to the power of n divided by 1 minus 5. Now, let's look at this part of the series. How many minus 5s do we have? Well, we've one from here, another one from here, another one from here. We've got n of them all together. So we've n minus 5s, which works out to minus 5n, of course. So we just add these together. That's what I've done up here. I've written it up here. If you like, you can do a little bit of simplifying. Minus 5 over 4 times minus 5 to the power of n will give us plus a quarter times 5 to the power of n plus 1. So we're adding powers here. 5 to the 1 by 5 to the n gives us 5 to the power of n plus 1. Then I've written down this term next, minus 5n, and the constant term, minus 5 quarters. That's minus 5 quarters times 1 is written at the end. Let's do a check for n equals 3. So for n equals 3, we have u1 plus u2 plus u3. Okay, we want the sum of the first n terms. So n is 3, so we just want 3 terms. So we just want to add these 3 terms together. We have 5 plus 25, which is 30, plus 125, which is 155. And then the minus 5s, we have 3 minus 5s, that's minus 15. So this gives us 140. Now let's plug n equals 3 into this thing. Okay, if we do that, we get a quarter times 5 to the power of 3 plus 1, or 5 to the power of 4, minus 5 times 3 minus 5 quarters. We have 0.25 multiplied by 5 to the power of 4 minus 15 minus 5 quarters. That's 1 1/4, or 1.25. So it checks out.